Hello everyone, I am Mr. Abhijit Vijay Kumar Shinde, Assistant Professor, Department of Physics, Padma Bhushan, Dr. Vasantrao Dada, Patil Mahavidyalay, Taskau. Today we are going to discuss the article Viscosity, in which we are going to focus 2 points. First is viscous force and second is coefficient of viscosity. So let's start with what do you mean by viscosity? Viscosity is nothing but a property of fluid by virtue of which it opposes its motion. The opposition given by fluid to its motion is known as viscosity. So let us derive the relation for viscous force, for which consider a plane surface over which fluid is flowing. For practical application, you can consider a river flowing on the riverbed. So let us start with considering the plane surface S. Let this be the plane surface S over which fluid is flowing. So let us consider fluid is made up of large number of layers moving parallel to the surface S. So initially we will consider different layers of fluid. This is first layer, this is second layer, this is third layer, this is fourth layer, and this is fifth layer, such that large number of layers combines to form a fluid. Then consider the layer which is at the bottom, that is in contact with the plane surface S, has velocity 0, that is it is stable in state, that is this layer has velocity 0. The layer above this layer has little bit extra velocity, let it be denoted by velocity v1. Above layer has velocity v2, which is little bit extra, then v3, and lastly topmost layer has velocity v4, which is maximum velocity of this bit of all this fluid. So we have considered a plane surfaces above which fluid is flowing. The bottom layer has velocity 0, and as we move from bottom to the top, velocity of the different layer gets increases. Let y be the height of fluid from the plane surface, that is S, from the bottom plane surface S, and as we move from bottom to the top, the velocity of different layer gets increases, and this increase in velocity is given by rate of change of velocity with respect to distance y. That is rate of change of velocity. The change in velocity of a different layer with respect to the distance is given by dv by dy and is known as velocity gradient. Is known as velocity gradient. So we can define velocity gradient as change in velocity of a different layer of fluid with respect to height. We have considered the velocity of the fluid at the bottom as 0 and the velocity of the top layer of the fluid as maximum. Here we have considered only 5 layers. Fluid is made up of large number of layers, up to which bottom layer has 0 velocity. It gets increases as we move away from the bottom layer, and the top layer has maximum velocity. Now we have to calculate the forces experienced by these layers. So let us consider this layer as Q layer, this layer as Q layer, and we want to calculate the force experienced by this layer Q. The layer below Q be denoted as P, the layer above Q is denoted as R. Let P, Q, R be three adjacent layers. Layer Q is middle layer, layer P is layer below layer Q, and layer R is layer above layer Q. Now we have considered the motion of the fluid in positive x direction, that is fluid is moving in this direction. The fluid is moving towards the left hand or towards the right hand side. So we want to calculate the different forces acting on layer Q. Now we can see that layer P, which is below the layer Q, has some low velocity or less velocity as compared to layer Q, while layer R, which is above the layer Q, has little bit more velocity or extra velocity than the layer Q. Hence, layer Q experiences two types of tangential forces. First tangential force is due to layer P and second tangential force is due to layer R. Now layer P drags down. Since it has low velocity than layer Q, it slows its motion, and this drag force is known as viscous force. Similarly, layer R try to increase the velocity of the layer Q. Hence, it tends to increase the velocity of layer Q. Hence, two opposite forces acts on layer P. So, you can see layer Q, this layer Q has two type of forces. First is this backward force due to layer P and this forward force due to layer R. Layer has forward force since layer R is moving faster than layer Q, and layer P has some backward or drag force since layer P is moving less than layer Q. Hence layer Q experiences two types of forces. One force that tries to move fast the layer Q and other force that tries to slower the speed of the layer Q. And these two tangential force or this combined force is known as viscous force. That is, viscous force is the total addition of forward force and backward force acting on the layer Q. This viscous force is directly proportional to the two quantities. So let us go to the next slide. So we will start with viscous force. Let be viscous force be denoted by F. Then viscous force is directly proportional to the velocity of the gradient and area of the flow of fluid. Viscous force is directly proportional to the velocity gradient dv by dy, that is change in velocity with respect to distance, and is also directly proportional to the area of flow of fluid, that is the viscous force acting on layer Q is directly proportional to the first velocity of the gradient and second this area through which the fluid is flowing. Okay. Now this viscous force is directly proportional to the area and velocity of the gradient. We know that velocity gradient tries to minimize the force. Hence, we can write down here negative sign. Negative sign indicates the viscous force tries to slow the motion of the fluid. Now, I will try to remove this proportionality constant by some specific constant, let it be eta. Then F is equal to, I want to remove this proportionality constant, so I will write the proportionality constant eta A into velocity gradient dv by dy. Here, eta is known as coefficient of viscosity. Eta is known as coefficient of viscosity. A is area of the fluid and dv by dy is the velocity gradient. F is the viscous force. From this viscous force, we can define the coefficient of viscosity eta as eta is equal to force, viscous force divided by area of the fluid into velocity gradient. Here we want the value of eta, so I will divide A and dv by dy to the left hand side. That is F divided by A into dv by dy is nothing but eta. So eta is coefficient of viscosity and is given as F divided by A into dV by dx. Hence, we can define eta or coefficient of viscosity as it is the viscous force acting on a fluid per unit area per unit velocity gradient. How we define the coefficient of viscosity eta? Coefficient of viscosity eta is defined as the viscous force F acting on a fluid per unit area per unit velocity gradient is known as coefficient of viscosity.